All right, let's go back over here to our idle window and actually run this. All right, we'll run drunk test. Default number of trials is 20. That seems good enough. We'll let it rip. Now if we look at it, we let it rip. We got some distances. And interestingly, if we look at it, we see that indeed, as our intuition had instructed us in the previous segment, the more steps, the further the drunk seems to be from the origin. Well, at this point, we could walk away happy and say, okay, we have the right answer. Life is good. Well, maybe. How do we know? How do we know there's not a bug in the step, in the simulation? Well, let's go back and do something we talked about when we talked about debugging. Remember when we talked about debugging, we said that it's always a good idea to run a test case where you know what the answer is and see if you get the expected answer. So let's do that here. I'm going to replace this line by num steps 0 and 1 because I have a pretty good intuition about how far the drunk should go in 0 steps. That is to say, nowhere. And we saw before that when the drunk takes 1 step, he should be moving exactly 1 step from the origin. Let's give this a try and see what happens. Okay, it did give us what we expected, so probably we can feel pretty good about the result. Let's go back to our original version now. And I'm gonna, well, let's just run it and see what we get again. All right, so what I want you to notice here is the first time we ran it, say with 10,000 steps. Did I say 100,000? Maybe that was what I had in the PowerPoint, but not what I have here. When we take 10,000 steps, the maximum was 248. Here, the maximum was 168. Should that make us nervous? Not at all. Remember, it is a random walk, and we do expect to have randomness. A trick worth knowing, however, is that sometimes we want to take the randomness out of a random walk or any random calculation. In particular, if we were to get the wrong answer and we want to debug it, it's nice to get reproducible results.